Welcome to week 5. Here we have a couple of themes for you to bear in mind as you go through this week. The first has to do with green chemistry. Green chemistry is an area of study with established industrial ecology principles that enables us to develop and deploy environmentally preferable chemical alternatives. With an important caveat: green chemistry is not sustainable chemistry. That is to say, green chemistry looks primarily at environmental issues, and remember that sustainability looks at environmental plus social plus economic. So green chemistry and sustainable chemistry are very different things. The second thing to remember is that green chemistry generally looks at immediate implications. So for example, it'll look at level 1 and level 2 effects. It will not necessarily look at level 3 effects. Remember that just because we can't predict them doesn't mean that level 3 effects don't occur. And so we need to be careful when we think about green chemistry to be aware of that and to pick that up in our analysis. For example, chlorofluorocarbons, CFCs, were very green chemicals when they were introduced because they replaced chemicals that were much more dangerous, much more harmful to human beings, much more dangerous in factories. Some of the chemicals that were in use then tended to explode. They were flammable. CFCs were very stable and did not have human health impacts. So CFCs, in that sense, were a perfect green chemical. But they degraded stratospheric ozone, which in turn created increased ultraviolet light on the Earth's surface, which had very serious health and environmental implications. The point is not that we shouldn't do green chemistry. The point is that we should never assume that a single set of tools is going to explain everything we need to know about a technology in a complex world like the one that we have. The second thing to remember is that when we're designing a technology, particularly a chemical technology, in general, we're not just designing that technology. Think about the antibacterial soaps that we use, for example. Because the antibacterials in that soap do not get broken down in water treatment, they are distributed back into the environment. What happens is you wash your hands with the soap, it kills the bacteria. The antibacterial chemicals go into the wastewater, they go into a treatment plant, but then they come out the other side virtually unchanged, which means that what we're doing when we design those chemicals is not just designing a chemical that cleans our hand, we are also designing a chemical that is going out and significantly affecting environmental systems because it continues out in the wastewater. So the result is we think we're designing a soap for people to use. What we're really doing is designing an Earth system that will in fact be changing environmental systems around the world. So we need to learn how to think more effectively about the broader impacts, the level 2 and level 3 impacts, if you will, of our systems, not just the level 1 impacts. We also are going to be looking at information technology this week. Information technology is very important primarily because it has changed so dramatically in the near recent past. Most of you are probably aware of Eric Schmidt, who's the ex-CEO of Google, who said that every 2 days we produce more information than was produced in all of human history up to 2003. Well, people argue with some of the specifics of that, but nobody argues with the general observation that every day we produce more information than we would produce in years and years, even in the 1950s or 1960s. So we have a lot more information. Why does that matter? Well, it matters because, among other things, human beings and their psychology, our cognitive systems, our communities, our societies, and our institutions are all information processing mechanisms. So if you dramatically change the amount of information that's out there and the speed at which it's circulating, you're going to have dramatic effects on humans, their institutions, and their cultures. We don't know what those effects are going to be. But it tells you that thinking about information technologies is not a simple task of simply figuring out how much material they use or how much energy they use. It's a far, far more complicated task when you really understand the overall integrated impacts of the technologies.